Today I'm going to talk about one special methodology that we tested this year in the Altai to register archaeological features, archaeological monuments and archaeological artifacts in a very straightforward, simple way in 3D. So it's really realistic. As we all know, for example, if we want to photograph an object, if we want to photograph something, or make a representation of it through a drawing, it's very difficult to make a realistic representation of it like it is in reality. I've taken an example. For example, this is one of the most famous types of Belgian cookies, and it's very difficult to really have all aspects of all visible aspects of that cookie in a picture. You don't have that. You only have a 2D representation of it, so you don't have all information about it, you don't have all visible characteristics of it. But imagine if there would be a technique to just document everything in 3D like it is in reality. This would be very good for archaeological heritage. Furthermore, if it would be possible to extract further information about it, like the shape of it and the dimension of it, with a very simple technique, that would be very good for archaeological heritage. It would be very simple to document archaeological monuments. It would be very simple to document petroglyphs. It would be very simple to document, for example, skeletons. And it would be even better if it's faster than ordinary techniques like drawing a site plan, if it's more detailed than your plans, if it's more detailed than your photograph, if you can get additional information about it, and if it's really a representation that is nearly a virtual reality, that is nearly a reality. So that would be very, very interesting for archaeology, because as we all know, archaeology is some kind of destruction if it excavates sites. So we only have one chance to document the things we saw in an excavation in situ once. So if there would be a way to document everything like it is, like it was in reality, it would be a major advantage. Then we can really, as an archaeologist, go back to our excavation and re-excavate our site just in 3D. And this is possible through a new technique that we started and tested this summer in the Altai. This is a technique that uses a Russian software program called Agisoft. It's developed by a company in Leningrad, and they also have a division in Moscow. And they were really the first ones to develop a software program to make 3D models of whatever you want, from cookies, packs of cigarettes, to archaeological monuments, to entire landscapes with just a couple of clicks on the computer. This is very interesting. This opens a lot of perspectives for really thorough documentation of archaeological heritage. So in this lecture I will give a short introduction about how this methodology works, what are the main advantages, how can we use it in archaeology, and what is the outcome for the archaeological heritage of the Altai. Because, as already mentioned in my last lecture yesterday, there is something going on with the heritage of the Altai. More and more is disappearing, and more is disappearing because of nature and of human, and due to human impact. So if we could make some kind of virtual preservation of those monuments, this would already be a major step forward, because then we can really preserve and do not lose all the information that can be lost if we don't act quite quick. So this class is going to be about this methodology that is very simple and everybody in this room can use it. So the structure will be as follows. First I will give a short introduction about the history of 3D and archaeology, because three-dimensional recording of archaeology is something that has already been taking place for 20 years, but really with this new methodology you will see that it's a major step forward, because old methodologies, old techniques to document archaeological heritage in 3D were very expensive, very difficult, and required a lot of technical skills that most archaeologists just don't have. In the second part of this presentation, I will elaborate a little bit on the principle of computer vision. This is how the program that makes those 3D models from ordinary photos works. Then I will present the workflow that we used in the Altai, and I will give quite a lot of examples of case studies that we applied in the Altai. So first, 3D in archaeology. The most registrations of archaeological heritage is done through drawings. All archaeologists in the room, or other people, know that when you excavate a site, you have to do a lot of drawing. That can be ordinary site plans that you draw. That can be transactions to archaeological features you have to draw and describe, and you have to take a picture. But this all takes quite a lot of time, but with this new technique we will be able to do it faster. And what are the disadvantages of those 2D registrations? They are already an interpretation. What you draw is what you see. If somebody else would draw it, it could be something completely different that can be on the paper. It's very slow. We mostly need two persons to draw 100 square meters a day of a site plan. It's limited in detail because you use just a pencil, and therefore it also has a limited amount of information. And it does not represent reality. It's just a representation in 2D. Furthermore, another technique, another problem with standard recording in archaeology is the recording of petroglyphs. Nowadays, and mostly, when a petroglyph or a piece of rock art is recorded, they use plastic sheets or they use some special wax to put on the petroglyph and get a trace of it, just to have a representation on a paper or on another element. But this is not good for the petroglyph. This is an example of a petroglyph in Ilangaj, and there they used a special sheet of paper that contains wax to put on the petroglyph and to have a representation of it. But what is the result? This is called an ablage. What is the result? That a lot of the wax stays on the petroglyph. As a consequence, the petroglyph is in fact destroyed. So this is not a good way of doing archaeology. And archaeologists should just register archaeology, not destroy it. Furthermore, this technique is very slow. So what could be the solution? A very good solution could be the documentation of a reality. And how do we do that? And how do we want to have a reality on our computer or on a TV that is in 3D? And this is really a good way of documenting archaeological heritage because it contains all metric information about the thing you register. For example, if you're going to register a building, your model, for example, a door in your model of a building will have the same metric information like in reality. So if your door is 2 meters high, in your model, your door will also be 2 meters high. And this is very interesting because this allows us to study and document archaeological heritage in a very detailed way. For example, the first example is one of the most important buildings of my town, and there they documented it with 3D, and all details of the building are really preserved. Another example is, for example, 2 years ago they did, I think 2 years or a year ago, they did a 3D capture of the Red Square in Moscow. This is also very interesting because then you have the Red Square in full detail, but what is also important and very useful is they can use this 3D model to really show heritage in a very realistic way, and not only heritage buildings, places in a very realistic way to tourists, put it on a website. So this is very interesting. Also for scientific needs, this is very interesting. And in archaeology, they have also been doing it for the last 20 years. For example, the first example to the left is an old building in Belgium. They documented with 3D before it was going to be destroyed because the building had some problems with stabilization, and it was sure that one day the building was going to collapse. So what did they do? They made a very realistic capture of the data. They really made a virtual reconstruction of the monument as it is now using 3D techniques. On the right you see the famous site of Stonehenge. Also this site has been documented in 3D, and this allows archaeologists to do research on the 3D model, but also to really have a good representation of the site itself, to show it to other people, to show it to other archaeologists, or to show it to other people that are interested in Stonehenge, for example. So, what are the common techniques that have been used the last 20 years to document archaeological heritage in 3D? The first one is laser scanning. This is based on a special device that emits lots of laser pulses, and uses this to measure the distance between the device and the archaeological heritage you want to document it, and as a result you have an information, you have a point cloud that represents every detail of the object. This is very fast, this is enormously accurate. If you would do it on a tree, you have even information on each leaf of the tree, but the main disadvantages are the price. It's very expensive. It costs around 80,000 rubles a day to use it. It's difficult to process the data because you really have to be a computer specialist to process the data, and you really need a lot of heavy equipment. For example, this is a laser scanner. It's very heavy, it's very difficult to take with you on archaeological research. Like in our prospection, it would be just mad to take on our prospection such a heavy piece of equipment with us. Furthermore, we're in the Altai for almost 30 days. Our university would be bankrupt if we would use such a device to do a really realistic 3D scanning of some valleys. So, this picture also shows how it works. The grey triangle represents the beam of lasers it emits to, for example, the bridge. And these laser pulses come back to the laser scanning device, and based on those laser pulses that return, the machine is able to make a 3D model of the thing you want to, the object you want to have measured in 3D. This is a very good technique, but it's very, very expensive. Another technique to document archaeological heritage or all other objects in 3D is using what we call photogrammetry or classical photogrammetry. It's based on overlap between scenes, and it uses the camera parameters to build a 3D model. It works a bit like the human eye. If you have two eyes, and with your two eyes you're able to see things in 3D. Your one eye sees one part, your other eye sees another part, and if you combine the two, you really are able to see things in 3D. And photogrammetry works in the same way. So, for example, for an airplane, you are able to make 3D models of the landscape with just overlapping pictures from the air, but the overlap between the two pictures is always 60%, like your eye, and the place from where the photo is taken is known. So the computer program is able to reconstruct the model based on the 60% overlap you have from your eye. This is a very good technique to have 3D representations in very high detail. It's much, much cheaper, but you really need a camera. You really need to have the position of your camera. All the parameters of your camera have to be known. What are parameters of a camera? Every lens you use on a camera has certain distortions, and to make a 3D model from a picture taken with a certain camera, you need to know all the distortions you have in your image. And this is often very difficult because cameras that have not a lot of distortions, and all distortions are known from that camera, are very expensive. They cost more than 2,000 euro, and the processing of those images is very, very, very slow because you have to do everything yourself. You have to enter all the distortion parameters, and you have to insert more and more information about the cameras. Furthermore, you really need heavy equipment on the field. You need a heavy camera, but you also need special devices to measure ground control points, that are points that are needed to integrate in your model and make it 3D. And it also uses quite difficult software. As I already told, you have to insert everything yourself, and it takes quite a long time to have something in 3D. An example is, we did a photogrammetric recording of the burial site of Tuekta, the very big kurgan, and it took a year to make a 3D model of the kurgan. With our methodology, we're able to make a 3D model of the kurgan in only 2 hours. So I will now show how it works, our methodology in the following slides. But first, let's have it about the disadvantages of the two techniques I just showed. So the traditional techniques like drawing and the traditional techniques like laser scanning and photogrammetry are not easy. They're not mobile. They're very difficult to take with you. For example, if you go looking for petroglyphs and you want to record the petroglyphs in great detail, it's really difficult to take the heavy laser scanner with you on the mountain and scan everything. This is not easy. Mostly they're very expensive. Not only to use it is very expensive to hire, but the software is also very expensive. It's not like you put a laser scanner somewhere, you do a scanning and you have a 3D model. You still have to do a lot of data processing, and this is very difficult and uses very expensive software. And you really have to know a lot about computers. But this is not what archaeologists need. Archaeologists, and especially archaeologists that mostly archaeological expeditions don't get a lot of funding compared to, for example, doctors or engineers. So we really need a simple technique that we can use ourselves, because most archaeologists, as for my colleagues, are not really good with computers. We want a technique that's really easy to handle in the fields. We want a technique that is very cheap, that doesn't cost a lot of money. We want a technique that's really effective, that we can really use to document very easy and very thorough. And there is a recent evolution in computer science. It's called computer vision, and this allows us to just make 3D models based on regular photographs. So if you just take a camera that everybody has, we take some pictures, some overlapping pictures of something you want to document in 3D, the program calculates for you a 3D model. And this computer program uses an approach that's called structure from motion. It uses similar points in different pictures. So similar points, for example, of this object. It looks in the different pictures for matching points, and it uses these matching points from different pictures to reconstruct the 3D model. So it literally uses an algorithm that is called structure from motion. It literally makes and rebuilds a structure from a moving camera. So, for example, camera 1 over there in the first picture, you see one face of the object. In the next picture, you see another face with overlap of the object, and in another picture, you see the same object from another side, but each time with overlap between the pictures. As a result, the computer program will be able to reconstruct the object in 3D using matching points. And this is very interesting, and this opens up really a lot of perspectives. For example, this is a Roman well that I excavated in my own village in Harelbeke in Flanders. And there we made some overlapping pictures of the well. So you can see above, we had one side, then we had the next side with a little bit, the next picture with overlap with the other picture. The next picture is again with overlap, but from another viewing point. So we made a lot of pictures around the object, and when we put all the pictures in the computer program, after some processing, the computer makes a complete 3D model of the site. So everything you see on your computer in your 3D model represents the reality. And this is really interesting. For example, The first picture in the left above is the point cloud we calculated from all the pictures. So the blue squares is the location of all the pictures. So you see, all those pictures have been taken around the object with sufficient overlap. And based on that overlap, we were able to make a 3D model. And the result for the other pictures. And this is really easy. And this is really a good thing for archaeology. Because of that, we are able to make a top view. We can just tell the computer, okay, now look to the structure from above, and we have a very good view of the structure from above. But we can also say, okay, I really want to study the width of the well. Okay, we say to the computer, okay, make a detailed representation, make a detailed picture of the front side of the well. And okay, we did it, and the result was that we had very detailed information about the well. We have information about the wood. We can even see the place where the nails were put into. You can even see traces when they made the wood, when they cut the wood into planks. You can even see them on the model. And this is really a big step forward, because normally when I excavated, I already excavated some wells some years before in Flanders, and there it was you had a very tiring technique. You had to take a measure and draw each side of the well in great detail. And this sometimes took several days before a complete well was captured and documented with drawing. But with this program, you just take pictures around it, and everybody that has used a digital photo camera knows that to take a picture and have a result with a digital photo camera is very easy. You just click, 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 click. You go around it, put it in the software, and you have a very detailed representation. You don't need to make a drawing anymore, because you have all details in your 3D model. Everything is also metric. If the planks are, for example, 60 or 80 centimeters long, in your model, on your computer, you'll be able to see that this plank is indeed 60 centimeters long. So you just can say, okay, if I want a good representation of the planks of the well, I don't need to go to my drawing. I just can say to the computer, okay, give me a good photograph of those planks, and then I can make in the computer a drawing. So the time you spend on the field to make drawings is severely shortened, because you don't need to make the drawings anymore. You can do it on the computer. Furthermore, a nice 3D model and a good picture tells us really a lot more about the archaeological object than just an ordinary photo, or an ordinary 2D photo, or just a drawing. So, another big advantage of our approach is that you don't really need a lot of material. You just need an ordinary camera, you need a computer, you need a tape measurer to measure distances. I will tell more about the use of the tape measure in the next slide. You need special glue, biodegradable glue that you can put on the object you want to photograph, and you can remove it without having glue stuck on your object. You need a pencil, you need a sheet of paper, and you need a GPS. And if you want to really work good and fast, and if you want to document a lot of archaeological objects or monuments in a time-efficient way, it's also useful to have two, what I call slaves, that help you to make and to take the pictures. Sinaru knows that, because he was one of my slaves that had to clean up my room afterwards. So it's really an easy way that you can document a lot of heritage, a lot of monuments in short time, in very great detail. So the first step of your work is just do a preparation. You have to stick little plastic or paper sheets. You have to glue them on, for example, the petroglyph, and you have to measure the distance between each cross, each point. This is necessary to make the model metric. This will allow you to measure a distance in the model. This will allow you to say, okay, I want to have a really realistic metric representation of it. This is really really a necessary step. In this preparation step, we also describe a little bit about the petroglyph panel or the monument. Where is it located? What are the distances between the points? How does it look like? And what is also important is to know what the data acquisition parameters are. With that I mean, was it a sunny day? How many pictures did I take? Which camera did I use? Which lens did I use? It's just general information that can help you in the other steps. Mostly you don't need information about your camera, but it can be useful. In this sheet of paper we also insert some information about the localization of the monuments, so our GPS coordinates. Next step, we take the pictures. This is very easy. Of archaeological monuments or big kurgans, for example, we use a pole and put a camera on it and just take some pictures and walk around it. And for the petroglyph panel, we just take overlapping pictures. This is an example of a movie we made. And we just first view all markers on the petroglyph panel. Then we measure the distance between it, and then we just start photographing. Take a lot of pictures. Then we measure the distances, describe everything, and we're done. That's very easy and very fast. This is an example of a petroglyph panel in the Carco Valley, the petroglyph panel of Saint-Berlou. It contains, I think, more than 200 or 300 single images. And normally, our colleague Professor Martinov from Kemerova and also from Gorno-Алтайский, I think, already has been going there with the students for a lot of years. And normally it takes almost 2 or 3 or even more if you have students that do not have as much experience. It can take up to 7 days or 5 days to document this panel with traditional techniques like drawing or tracing. But with our technique, it was possible to document the entire petroglyph panel in just 1 hour. So it really makes our work much easier and much faster. Once all pictures have been taken, the image processing, so the process where we extract the 3D information from the images, can start. And the first step is the alignment step. The computer is looking for points that match. So you can build a 3D point cloud from all points that match between the images. In this step you also try to position the place from where the picture is taken. This is also very useful to make in the next step a 3D model with the pictures projected on it to make that. This is an example we did for the Kalbaktash site. The site of Kalbaktash is really big. There are lots of archaeological petroglyphs over there, too many to document in a very easy way. For example, the Academy of Novosibirsk has worked in Kalbaktash for many years to document all petroglyphs, and it took really a long time and a big team to document everything very good and very carefully. And it's really necessary that there is a good documentation, a good realistic documentation of the Kalbaktash site, because large parts of the Kalbaktash site are being eroded. The petroglyphs are on a type of rock that doesn't preserve very good. If there is a lot of ice, there's a lot of snow, there's a lot of wind, the petroglyphs are degrade. And as a result, we saw that this year a lot of petroglyphs are just falling off the rocks. So it's really necessary that we have a good, realistic representation and a good documentation for both the means of preservation, but also because we can then really start to study it in more and very great detail. So within the program, we inserted all, I think, 300 pictures we took of that single petroglyph panel, and the computer calculated a 3D model of it. It first looked for all correlating points, for all matching points on each picture. And then it tries to calculate from which place all these pictures were taken. These are again the blue squares represent one picture and oriented towards the 3D model. This is not only possible for petroglyphs, this is also a technique that we use to document archaeological monuments in great detail. So we took pictures around the monuments on a pole, we put them into the program, and the program calculated from which place was this picture taken, and what are the matching points between the different photographs, and where do these matching points fit inside the 3D model. So they really make a 3D model from the matching points. And the next step, the computer program uses the matching points to make a 3D elevation model of the site. This is not an ordinary 3D model like with the cookie with the picture on, but this is just a representation of all height differences inside the model. And this is a very good way to really study things that you cannot see on the picture. For example, for this monument, if you look to the picture, you see a lot of stones, but you don't have an idea which stone is higher than the other stones. But if you just make an elevation model of it, you can really have high information about each stone on the monument. And this is really interesting, this is really realistic, and this is really detailed. This enables us to study, for example, what are the general stones that they used, how big were they, and for example, you can see here in the monument that they used larger stones around the monument and they filled the monument inside with smaller stones. You would also be able to see that on an ordinary photograph, but you wouldn't be able to really measure the dimensions of each stone. Another example. But also for petroglyphs this is very useful, because here on this picture, it's not so clear on the screen, but you can really see the petroglyph into the elevation model. And this is really interesting because there is, within the science of rock art, there is a side science that's called tracétologie, and that uses this kind of elevation model to study which material they used to make the petroglyph. Because when you now have an elevation model, you can easily see, okay, they made this petroglyph with a stone, with a piece of horn, or they use it with metal. This is now visible from this elevation model. And the next step, the computer program puts all the pictures you've taken, they put it on the 3D model, on the elevation model, so you really have a very detailed representation that's a bit like the reality. For example, to the right you see a very nice Isfayani from the Jazalj Valley, and in our 3D model we just have that Isfayani in a realistic reproduction. It's really like it is in reality. Every detail is on it. You can augment it, so you can say, okay, I want to see another side of the Isfayani, so you can really look to it the way it really is. You can do that for archaeological monuments too, and for us that's a very big advantage, because we're only able to go to the Altai and do field work for, let's say, 6 or 5 weeks. So when we come home, we have to process all the information, and when we come home, we only can depend on our writings and on our pictures, or ordinary pictures, and on our drawings we made. But with this technique, we can easily make some overlapping pictures, and okay, when we say, okay, we want to study a monument in more detail, we say, okay, let's look to the 3D model, and we'll have an idea about the realistic, we'll have an idea that's really realistic and detailed about how the monument looks like in the fields. This is very easy and very useful for us, because in that way we don't have to go back to a certain monument each year because we need some more information about it. We just take some pictures, we look on our computer, and voila, we have a very detailed representation of a monument. Another big and important step in the processing of all the images towards a realistic 3D model is by making it a geometrical correct model. That means that your model, if, like I said before, with the house, if you have a door that is that's really, for example, 2 meters high, It should also be in your model 2 meters high. And you can do that by using the little plastic crosses we glued on the monument, and then we measure on the field each distance between each cross. We say to the computer the distance between that cross is in the real world, for example, 4 centimeters, and then the computer will calculate for the entire model realistic geometrical information. Then you can say, okay, now I want information, what is the distance between that and that point, and he will tell us the distance in reality. For example, for this model, all the little flags you can see are correction points, and if I say, okay, I want to the computer between point 11 and point 23 or 29, it's difficult to see. The real distance in the real world is 10 centimeters. I will be able to measure the distance between, for example, point 16 and point 20, and it will be, for example, 30 centimeters, and this will be the same distance like it is in reality. So what you get from this program is really a realistic representation, a metric realistic representation of what you see. For example, this is the test we did. We compared all the distances that we measured on the field with distances it has in the model. So we said, for example, for this case, we said, okay, the distance between point 1 and 2, we said to the computer, this is 7.54 centimeter. And then we measured all the distances between the other points that we also measured on the field, and we compared them. So we compared the measurements in the model with the measurements in the real world. And as a result, we got an accuracy of 1 centimeter. And this is, you're not able to have an accuracy of 1 centimeter just by drawing it. For example, for a petroglyph panel, we did the same, and we even got to a bigger accuracy below 1 centimeter. So, some examples. We had some monuments in the Altai where we're having a little bit of problem with, because we really need detailed information about them, but it's really difficult to have detailed information of them because our ordinary techniques, just an ordinary photograph or a drawing, are not sufficient enough to have a very detailed representation of how it is in reality. The first element was rock art, because we didn't want to use the old techniques that are really bad for the petroglyphs. We chose to use our new technology to document everything in 3D, and the result was we can make very realistic representations of a 3D model. This is an example of the petroglyph panel, near Pinchik-Dibong. And we have a very detailed 3D model where even all petroglyphs are visible on the 3D elevation model. We also wanted to, because we worked together with Dr. Gертьяна Pletza from the Novosibirsk Academy, and he has a project in Ilangraj, and he wants to redocument all petroglyphs of the valley. The valley has been surveyed in the 70s and the 80s, I think, by Okladnikov, but this was done in an old-fashioned way and was done with old techniques, so it's not very detailed. And Dima Cheremizin really wanted to re-inventory everything, to really compare both data sets, but also to do a thorough analysis, because Okladnikov was not able to document the very fine petroglyphs. There are very small petroglyphs in Ilangraj that are not bigger than 2 or 3 centimeters and that are carved with a very thin needle out of the rock. So it's very difficult to document it by drawing it, because your pencil or your mark is already thicker than the needle they used. So he said, okay, with your new technique, maybe you can help me. And okay, we went to Ilangraj. Our first goal was to inventory all small petroglyphs, but then we said, okay, it's going very good, let's try to do everything. So we did everything. We have documented more than 280 panels In total, we have more than 10,000 of figures on it, single representations, and we did it in 4 days. Osladnikov did it in 7 years. So that's really a big step forward. And there were long days where we had to take a lot of pictures, but we really were able to document the site in almost 100 times faster than it was done with traditional techniques. This is an example. For example, this is a very big rock. This rock is, I think, its dimension is 6 by 4 meters. It would take almost 1 month to document it with old techniques. But with our technique, it was really possible to document it in 2 or 3 hours. So it's really a step forward in methodology. All petroglyphs are also all petroglyphs. Each of the 10,000 petroglyphs we documented are documented in very detailed way. We have even height information about each petroglyph, so we have data sets that's really realistic, that really opens up new possibilities for further research, and it's very fast and it's very cheap. You have to see, we used an ordinary camera, we just used a tape measure and an ordinary GPS, a sheet of paper and a computer program. And the computer program also didn't cost that much. We only paid, I think, 400 euros, that's roughly 16,000 rubles to buy the computer program, and you were able to process everything. You have to take into account, if you would go 7 years to the same valley again, to document everything, you would pay a lot more than with our technique. In 4 days, everything is documented. You can go to the next valley. We were even able to document the very, very small petroglyphs that are occur on the stone panels of Ilan. This is an example of a recent inscription that's only larger than 1 centimeter. It would be very impossible to draw it in a very good way, but with our technique we just took some pictures of it, put it in our computer, zoomed in on it in the 3D model. We said to the 3D model, okay, make a picture of this. We draw it over in a computer program, and okay, we have the petroglyph in very detail, and we have information on petroglyphs that would be otherwise almost impossible to document. You know, each scratch that they made with their needle to make this petroglyph, we can see it on the computer. We can even see scratches that you cannot see with your human eye. So this is really, really a good technique. We also did it in Kalbaktash. As I already said before, there are some preservation problems with Kalbaktash, and it's a very big complex. So we really wanted, because it's degrading fast, we wanted to go towards a virtual preservation. That's not an optimal way of preservation, but we really wanted to have a preservation on our computer about how did the Kalbaktash site look like in 2011. And okay, we just took the pictures. We're not ready with it yet because it takes quite some time to process all the images, and by next year we'll have about 5 big panels of Kalbaktash. We'll have very detailed information, and it will be preserved on the computer. And each detail of the site will be accessible on a 3D model. Another test we did was on Isfayani of Jazater. These Isfayani are also facing severe and difficult situations towards preservation. For example, in my first lecture I said that already some Isfayani disappeared since 2005. So it was really necessary to document them in a very good way before they will be destroyed and there will be no trace of them anymore. Furthermore, it's really difficult as for an archaeologist to make a drawing of such a Isfayani. First of all, not all decorations are visible to the human eye. Secondly, it's very difficult to take a piece of paper and draw it over because it's really not easy to draw. And thirdly, it also takes a lot of time to draw them. So we tested our technique on it, and we did several tests on the 2 of our 3 main sites of Gorno-Aaltai. And in one site we wanted to document an Isfayani, or a sculptured Turkic warrior, that was very eroded, and it was almost impossible to see all decorations. So this is the most right picture. You can see one of his arms and maybe a second, but you cannot really see more details. So we put it in a 3D model, we take pictures of it, and you see the middle picture. Oh, on the digital elevation model, all details show up. You can see his sword, you can see his belt, you can see both of his arms, you can even see the beginning of his chin. So this is really a great technique to even document sites that are not that visible anymore. In the second test, we also wanted to document a complete site. You know, as I told already before, these Turkic sculptured stones stand along and in relation to another site, to the Turkic enclosures, to the Ogradka. So we wanted really to test and push the frontiers and look, okay, how much can we document? How much can this program really do? So we said, okay, let's look for a site with several sculptured stones, with a lot of stones around it, and let's try to document it in a very fast time. So we did. This is the result. It worked out very good. We were able to document the 3 sites, so the 3 monuments, and we were also able to document the 2 standing stones in very big detail. And this is a photo of it, so we really have every stone of the Ogradka, and we have every detail about the Isfayani, or the Turkic warrior. For example, these are the 2 very detailed photos of the 3D model, so we have really every detail about the site. Also from above, every stone is in our model. If you want to make a very detailed drawing of the site of the Ogradka in relationship to the Turkic stones, we can just put it into a drawing program on the computer and start to draw it over. If you want to have information about each stone, how big are the stones, we can just use the digital elevation model to really map every detail. Another problem we had in the Altai were with the so-called dwellings in Justiz. These are small, square monuments. We didn't have much information about their date and their function. And with what is also striking for these monuments, they never occur in the same pattern. There are lots of types. It's not always an ordinary square. You have triangles, you have circles, you have even dwellings that have the shape of a shovel. And because we wanted to document the different types, then in the next stage we can say, okay, let's do some research and which types then we can say within our research question, okay, now we want to really reveal the truth about the different types. So we can say, okay, let's excavate some types, and then maybe this type will be older than that type, or that type will have a different date. But before we can really have information about that, information about the meaning of different types, we really wanted to have very detailed maps about the different types, because we knew that there were some differences, but it was really difficult to document the various types, because 2 types can be just different by another stone setting, and it would be very difficult to draw and photograph every stone in detail. So we tried to do our technique. We first did it on an ordinary dwelling, just a square one that has a little stone concentration in the middle, and we used our program to make really detailed maps from above, so we have information about each stone setting, so we can draw it over and say, okay, this is a simple dwelling, a square dwelling with in the middle a hearth. Okay, this is another type. This is a square one that has line starting from the center. Okay, we have a map about this type. If we call that type B, for example, and when we go back to the field, we can say if we see another dwelling, okay, this is type B. There are even more difficult types. This is a tripartite. It has 3 different rooms in it, and we really never were able to make a good map of it because it contained so many stones, and if we would have to draw every stone, we still would be in justice drawing every stone. So we just took our pole, put our camera on it, walked around it, took the pictures, made a 3D model, used the 3D model to make very detailed drawings. And okay, it doesn't show good on the projector, but we were able to have a very detailed map. And then, our next step, we could alter our research question and say, okay, now we really want to learn something more about the different types, and we're going to select some types to excavate. And then we had a little argument with my boss, with Jean. He's an old-fashioned archaeologist. He's used to make drawings. But we said, okay, no, we're not going to make drawings. We're going to be one of the first in the world to make 3D models of our excavation. And as we did, so we were able, just from different pictures from our pole, we were able to make a 3D model of our excavation. We can use this information to make site plans, but we can also use this information to, okay, there was a difficulty with one of the elements of the excavation, let's go back to the excavation, let's go back to the 3D model. And it's very simple. We've taken 40 pictures around it, we made a magnetic model, and we have all information about the excavation. We have also excavated another monument. We also took information from it, and we were able to have all the details of every stone of the excavation. So, it's quite clear for me that this is a good step forward for documentation of archaeological heritage. The model we make to get our information from it is very accurate. Like I already showed in the table, it has just an error between 1 millimeter and 1 centimeter. So this is a very big step forward. Furthermore, it's very accurate, and it's 10 times more accurate than classical. It's 10 times faster than classic drawings. Secondly, it's a very simple technique. We just take overlapping pictures, put them in the computer, and an hour later you have a 3D model. It's very, very simple. It's also highly mobile. It's a very easy technique. You just need a camera and you start taking pictures, and you don't need difficult and heavy equipment. For example, for an excavation, all people for an excavation use a height meter to measure the height of the different traces. No, that's not necessary anymore, because that height information is inside your 3D model. It's also very cheap. You can use very simple cameras to do it. We were able to make 3D models using the camera of my iPhone or a very easy and quite cheap Samsung, a very simple camera. And what is for me, one of the most important aspects, certainly for rock art study, is that it's non-invasive. It's not worsening the preservation of your piece of heritage. For example, with the uplage, your rock art, your petroglyph is destroyed. With our technique, it's not destroyed. And on the contrary, it's documented without almost touching it. And it's 15 times more faster than ordinary techniques. So it's easy, it's cheap, and it's very good. So everybody can really use it. It's very simple. The manual of Agisov is in Russian, so everybody in Russia can use it for archaeological means, because the program is in Russian. It's made by Russians, you can ask them questions. They also luckily speak English, so that I can contact them. So it's very easy, everybody can use it, it's very cheap. So everybody please start to use it, because it's very good. It's much, much better. But there is one disadvantage. You can get as much as information from your 3D model as you want, but sometimes you need a really good computer to acquire the highest and the fullest detail. For example, the example that I showed of the well, this is very detailed. Every detail of the wood every detail of the nail, every little fraction of the wood, really, every element of the sand around it is in the model, you're able to see it on the computer. But this needs a very good computer to process it. For example, for the petrol disc, it's easy and it's not efficient, it's not difficult for your computer to make a 3D model from it. It doesn't need a lot of time to process if you just want a representation of your site. But if you want every detail about every piece of rock, you need a good computer to acquire this high detail. So, that's all. Are there any questions?
In this time you made 3D model of lots of archaeological monuments, especially in the Dutch region, and I know that these pictures of this monument and 3D model will be only in on paper in your research program. And to tell the truth, I'm very sorry, but you know that our local population, they don't very like archaeology, and they want to get on exchange something from your work or laboratories to see the results of your work. And would it be possible for our local population to see that 3D model, and will it be accessible, and where can we see this 3D model?
It's a good comment. I thought about it after we spoke in Angash with the photographer. He was also asking the same question, because we used this technique to really have a good documentation of the sites, to make a paper representation of, to make drawings from it. But in the meanwhile, I've been also using the technique in Belgium, and a lot of people are interested in archaeology, but it's very difficult to show them what archaeology is. So we really were looking how can we exchange it, and now we found a way to export our 3D model into a PDF file, and you can just, with your mouse, you can, like with a cookie, okay, where is the cookie? Where is the cookie? So, like with the cookie in the PDF file, you just can do like this. You can zoom in. So we will now be able to do that for archaeological monuments too. So the 3D models will be accessible. They're going to be accessible, don't be afraid, but they can be accessible. Everybody can open them. Everybody can look to them. Everybody can use their mouse to move things. And now, so we already found a format to exchange it, and now we're looking how can we put that on the internet, or how can we put that on sites where people can log into to get the information. One of the projects that we're now doing is to make a complete 3D model of an entire valley. So you have a complete 3D virtual model of the Caracol Valley. So you'll be able to log into a website and just walk through the valley as it is. You'll be able to see every detail. You'll be able to see not the people, because you don't have the people on the website, but you'll be able to see every house. You'll be able to see every detail of every monument. So one of the next steps is going to be put everything on the internet, but still this is probably going to be a difficult thing, because a lot of people in the villages don't have internet. So it's difficult to give them a computer and say, here you have a 3D model, that would be too expensive. But one of the projects that I'm now looking into, together with you and the lady from Toulouse, is use that information really to tell more about the petroglyphs, so they are preserved. And the next step, everybody will be able to log into the internet. For example, they go to a map in Google Earth, and there they can zoom, for example, to Kalpatash, and because every monument also has a GPS localization, they will be able to click on the monument and will be able to see it in 3D. But that's the future. First we have to really process all the images, because we took somewhat over 15,000 images, so that needs a lot of time to be processed. I've already processed 25% of it. I hope by this summer I've processed 100% of it, and then we still have to, with processing I mean drawing, interpreting, and put everything into a publication. So the processing takes a long time, but you have the same as an ordinary technique. And then it's really the goal to make some kind of internet site where people can access their monuments. But first we have to go back to the local population and ask them if it's okay to display the monuments on the internet. Because maybe some people will have difficulties with displaying the monuments of somebody that died on the internet. The same problem with the footprints. Maybe people won't be glad to that everything is just shown on the internet. Maybe there will be people that have bad intentions and can go to those places and rob them if they see them, particular localization. So that's the next step what we should do. But for example, I don't think it should be a problem for Gorno-Aaltaich because everybody knows where it is. Maybe first, yes. Yeah?
My second question is about the gas pipeline. We know that lots of archaeological monuments will be destroyed because of gas pipeline, and our archaeologists will have to excavate all of them during a year.
Right.
And will it be possible to make a 3D model of these monuments?
One of the things I'm going from Gorno-Aaltaich to is to have a talk with one of the archaeologists of the academy, Dima Cherengizmi. He will be responsible for some excavations. And one of my things that I really want to have, and this is going to be expensive and almost impossible, but I want to have a 3D documentation of the complete landscape before the pipeline comes. So not only each monument, so I really want to have each monument in detail that's going to be destroyed, or be excavated, but I also want the landscape around it, because it's really important that you also have the information what you see around you. But that will be quite difficult. You can do that easily with a plane or a helicopter flying over it and take a lot of pictures. We already did it before in Flanders, so why shouldn't we do it in Altai? And Dima also told me that there are going to be some petroglyph panels destroyed by the pipeline, and it would be really good to just document the whole rock at one time. Unfortunately, this is not we haven't been asked to do it, and we'll try to be involved in the project. Other people can also use our methodology because a big article is coming out by the end of the year about this methods, written by me and Wouter and Jean, and they can do it also. I've learned it's pretty easy. Just put the images into the computer and you have a 3D model. For example, for the cookie, I took those images yesterday. I was watching the movie, let the computer calculate, and I have a 3D model, so it's very easy. Other questions?
Do you know anybody from Russia archaeologists who use this 3D model?
No, there are some universities in Europe that use it or start to use it, but it's really our university that's one of the first to use this kind of program. Other universities use the laser scanning or photogrammetry, but we're one of the first that uses it. There's also a university in Austria, in Vienna, that uses it, but it's also a colleague of ours that works there, and there's also a university in England, Sheffield, that uses it. And it's the colleague that works in Vienna that really started to work with it and started to help making the program. It works together with the people from Agisoft in Moscow. And another interesting thing is you can download the program for free from the internet. You can play with it, you can use it. It's on the website agisoft.ru. You can download it from there, you can learn to work with it, and once you really want to make 3D models that you want to mail to other people. If you really want to do professional things with it, then you can purchase, you can buy it. But it's free to use as long as you don't do anything with it. Don't do anything with it if you don't export the results. So isoft.ru, and it's free.
Нет больше вопросов, да? Ну тогда поблагодарим нашего лектора. Нам 4 дня отсутствия работы.
Okay, thank you.